Async Await. Async Await. What is Async Await? Why does it exist? Why do we need it? And when should we use it? This is episode 13 of a 10-part series called, you know what, let's make it 20. This is getting ridiculous. 20 things JavaScript developers should know, but probably don't. This is episode 13, Async Await. Plus a bunch of updates and announcements at the end, so stick around. Let's do it. In episode 11, I showed you what asynchronous programming is versus synchronous. We used callbacks to achieve async. Then in episode 12, we took that example and converted it into using promises. In this episode, we'll take the same example and convert it to use async await alongside promises. If you haven't seen those two episodes first, I recommend you do that. Then I'll show you a couple of examples, more realistic examples, and we'll take it from there. If you remember from the promise episode, there are two parts to any promise: the promise creator and the promise receiver. In other words, there is a part of your code that creates a promise and returns it, like this function. And then there is another part of your code that receives that promise and does something to it, using the then and catch block. We can actually get rid of the promise variable here and write it like this, a little simpler. So take a look at this result variable, right? It's inside a then block. That kind of annoys me, right? I don't like the fact that it's inside a separate block. But we need to do that because this is async code, right? But wouldn't it be cool if we could write async code as if it was synchronous? Like regular serial code reading from top to bottom one line at a time, instead of nesting code inside then code blocks? Something like this, where we just create the result variable and assign it to the return value of this getData function. Well, no, because getData doesn't return the actual value, right? It returns the promise of that value that will resolve sometime in the future. I explain in full detail over here in episode 11, or in this 1-minute YouTube short about promises. The bottom line is JavaScript thinks this is synchronous code and doesn't wait around for the function's async operation. Unless we put await in front of the function invocation. What? Is that right? Hold on. Espresso. Are you serious? I mean, we can just do this by putting await in front of the function? Well, let's find out. Craig, to the browser. Alrighty, so let's create a promise. Let's actually first create our function, getData. And what does it do? It returns a new promise. And the promise resolve. This should be familiar to you already if you've watched episode 11. 12 actually, one of those. So we knew we get a resolve and a reject. We're just gonna do the resolve real quick. I'm gonna fake a little timeout action, 1 millisecond, because I wanna be a dick to the browser. Then I'll do a resolve, and I say number 46, because why not? 46 and 2, it's the enemy. Okay, then what do I want to do? Okay, so now let's just call our function and see what happens. Const result equals getData. Then what do I want to do? I want to console log my result. And I just found out that I have a typo. Set timeout, and we do that, and boom. Okay, so it's obviously just a promise. Now, what if I put await? Like I was saying, it's gonna work. I put await in front of it, and boom, syntax error. Await is only valid in async, in async functions and the top level bodies of modules. Okay, so what does that mean? So what's happening here? The reason why it's called async await is because in order to use await, you need to use async. In other words, await right here is only usable inside functions that are async. And since we're not inside a function, let alone an async function, we can't really use it. That doesn't like it. It's gonna yell at us. So let's put it in a function first. Function, I'm gonna call this start. Not a great name, but it will do for now. And so now we're inside a function. But it still says it doesn't like it because the function has to be async. So how do I make an async function? I just put async in front of the function. That was easy. Now, what do I have to do to make this work? I just have to call my function, start, and the result shows up, 46. So that is pretty freaking cool, right? So here's the magic. I can call getData as if it was just a synchronous function, right? And I can assign its value to result, whatever it returns to result, but not the promise, right? It does return a promise, but it actually waits for the promise to resolve or reject. We'll take a look at that in a second. Assigns the value to result, and I can console log 46. By the way, I console log just to show you that now I have access to the real value that I eventually wanted to get, the resolve, the fulfilled value of that promise. But obviously, you want to do more than just results, right? You can do whatever you want to do here. So usually I just use console log just to show you that you now have access to 46. So this is a difference between this and I'm gonna do one more function just to put them side by side so you can see. As a reminder, we don't want to assign it. We can say dot then again data or result, I guess. I'm trying to be generous here to our then block and this syntax that we looked at before. So I can say console.log result. So at this point, I will receive it and I'll be fine. Right, so I think this is fine. I don't think I left anything out here. So it's the difference between this and this. So which one do you like more? I mean, I, for one, much rather write it like a synchronous kind of top to bottom kind of way instead of creating these catch blocks and then blocks. And oh yeah, so if I want to catch the error, I'm going to have to do the catch and so on and so forth, right? We've done that in episode 12. So I'm going to get rid of this. And again, the point is that I can start using the result of my async operation as a regular variable as opposed to some internal variable that's declared inside a then block. So let's simplify a little bit, actually, because right now we're faking it, right? We're faking an async operation. So what if I don't want to use timeout anymore? So what do we do instead? We can use, let me get rid of this getData because it's kind of like a middleman function that I wrote. Let's use fetch. Fetch is a native browser feature. And you can just use fetch to call backend endpoints and receive data. So I'm just gonna use that instead of using this fake set timeout that I had. By the way, fetch is the topic of episode 14, so next episode. So make sure you check that out. Una macchiato. I can't focus. So we know fetch returns a promise, so I can treat it the same way as I did with my getData function. I'm actually gonna copy this URL from where you can't see because I don't wanna have to type it. So let me zoom out a little bit. Well, maybe I can do this. I wanna try and get everybody on the same line. Okay. So hopefully you can still see that. So I'm going to wait for the results of the fetch call. And then something funny about fetch is the result is actually, it needs to be JSONified. So let's just say data that comes back and then the actual result, which we were looking for before, it has to do another await on data.json. I'll explain all this next week, maybe, whenever I do the next episode. And then I do console.log result. Let's see where we end up. Whoa, that's a lot of stuff I don't need. Okay, so I need result dot, what does this object look like? Has properties, I think. Properties. Yep, it has that. And then whoa, it gives me so much stuff. So this is actually the specifics of this particular API I'm using, the weather API from the government. And it gives you way too much. And I don't need, what do I have? One. So I'm just getting the latest short forecast. Yep, let's do the boom and that. So, okay, very nice. I actually am able to get some data from a real API, get my data, and write it in a way that reads top to bottom. There's no additional code block or any then or catch that I need to create. So the result variable is now pretty much accessible for me to use. and I can do whatever I want to do with it. So that's the magic. And so let's compare it now to, I'll write this one more time as a start to, like I did before, as if this was written in the old format. Then I can get, what do we call that? Data. So data comes back, and then what do I want to do? I want to do data.json. Yep, and then there will be another then, which will give me result. I could be naming these a little bit better, but I'm not. So if I do this, right, so let's do that. If I do start to, do I have any bugs? Nope, it's fine. It does the exact same thing. So it's the difference between these two. Between this mess, which, oh, look at all this indentation and all this weirdness, versus pretty straightforward lines top to bottom, right? Very nice. So a few important points about async await. Async await has to be done, both of those keywords have to be used together. Like you saw in the beginning, it was yelling at me when I was using await without using async. You're just gonna get a syntax error, except for two pretty common scenarios. So those two are await can be used without async with the JavaScript modules. Now, I don't want to encourage or discourage it. That's kind of up to you. I'm going to put a link below to MDN. You can read more about it on MDN and decide whether you want to use it or use that or not. And the second thing is Chrome DevTools actually allows you to write await and use await without the usage of async. As of Chrome 62. So it's been a while. Chrome is up to, I don't know when I'm shooting this, it's around 106 or 107, 108. So it's been a while. So Chrome DevTools, which is something I use a lot, which you probably have seen if you've seen the previous episodes. I use it a lot for debugging and for testing things out and just around with JavaScript. Chrome DevTools assume that you're in I believe they just create some kind of a JavaScript modules where you can use await without using async. So just keep that in mind. If in case you don't see the syntax error and you think, wait a minute, was Sina bullshitting me about those two keywords having to be used together? No, that's why. So DevTools gives you that kind of luxury. Number two, async await only affects the promise receiver, not the creator. The creator implementation stays the same. So when using async await, you don't change the promise creation side, you can leave that alone. You only change how you handle the promise, right? So it's just a nicer syntax to write versus the then block. Three, you can put await in front of any function that returns a promise. Like you saw, we did that with getData, which was a custom function that I wrote that returned a promise. And we also saw it done with fetch, which is something that's just native to the browser. Four, any function almost can become async. So can I put async in front of, let's say, object methods? Sure you can. Oli, here's an object called me, and it has a method called say hello that returns a string. It doesn't even return a promise. And as soon as I put async in front of the function or method, boom, now it's async. This means I can perform any async operation inside the function and await the result. I don't have to do anything async in there, but if I did, I could write it with await and it would be pretty easy, something like this. And also you might have noticed the next point number 5, async functions return a promise by default, right? So if you convert a function to be async, it will make your function return a promise by default. Even if you explicitly return something else, like a primitive, like a string or something, it doesn't care. Check out the Oli example. It looks like it just returns a string, right? But it doesn't. It returns a promise, a resolved promise, right? The promise isn't pending, but it is a promise that's resolved. Number 6, one of my favorite things, or one of the most important and neglected JavaScript skills, which I should probably dedicate a whole episode to, is error handling. So in episode 12 with promises, I showed you how to handle errors using the catch block. We spent almost half of that episode talking about error handling. When we start using async await and we don't have the then block, then we probably don't have the catch block either, right? Well, kind of. You can use a catch block with await, but also you can catch the error using a much more old school method called try catch. Let me show you how it works. So back to the browser. Let me just copy this from here because we already wrote it. And so instead of resolve, right, this is what we had before. I am going to reject and say something went wrong. And so now I'm going to async, write an async function just like before, start, and I'm going to invoke it. And what am I going to do? So I'm going to do the exact same thing. Let's actually just write it first, and then we can add the try catch. Result await get data. So it says something went wrong on uncaught in promise. If I now put a try catch in here, actually move my thing here, catch, it's going to accept an error, and console.log, let's do one of these, error, and I can do that, error. And it says, so now we're catching our error inside the catch block and says, error, something went wrong. So this error comes from this reject. So it's kind of similar to the catch block of promises that we looked at in episode 12, but it's slightly different in the way we write it. Now, with that said, you can still, I'm gonna do start two one more time and compare them side by side. Start two, if I do a regular function and do this and do this, boom, I can do a dot catch and say error, whoopsie daisy. So this is my catch block. So you could mix and match them if you really wanted to, but there's a couple of problems here. Like if I do a catch, so here's where it gets kind of messy. Let me comment that out for a second. So let's say this is the happy scenario, right? I have that, okay? And resolve, let's say we resolve it, right? And it's not something went wrong, reject, but I won't call the reject. I say, here's your data. Here is your data. And we're gonna resolve. So great, this is in a normal situation with a success scenario. This is fine, this code works. But as soon as I add the catch block to it, but I still want to log my result because I still want to, I want to use the result variable, the value that comes back from this. The problem is if it rejects it, it does go into the catch block, but it's still the rest of my code is still gonna run. So that produces a few really big issues for me. For one thing, this is bad because we don't want any of our success logic, which is here, this console log. Again, this is just a replacement for what we would normally do if it was successful. Say I wanna add it to the DOM, or I wanna pass it to another function to do some kind of calculation, or whatever else I wanna do with it. This code will still run even if I have a catch block. So this could potentially create a bunch of different bugs for me. I don't want this code to run if there is a catch, right? So if the promise was rejected, my success code is still gonna run. That's not good. But also we need to separate out our success logic from our failure logic for a bunch of different reasons. For readability, for testability, for organization. If I do this, they're kind of entangled with each other. They're too close to one another. Versus if I get rid of that and start, let's do our start usual. My console.log success, success. I'm gonna try to type it the same way as my failure, so they're kind of similar. What I can do is I can totally separate out these things, and I can say, I can create separate functions for organization on success. I can say, do that on success and on failure. I can create another function called on failure. Right? And so what's cool about this is that now my success handler and my failure handlers are totally separate, right? And lastly, what's the point of writing async await if you're not going to take advantage of the synchronous looking nature of it? So that's why in the industry, most people as a standard use try catch when they use async await. So I'm gonna get rid of all this clutter here just to show you a little bit more cleanly where we ended up. This is gonna be my failure and this is gonna be my success. And this is pretty nice, right? Now, are you gonna be able to find some asshole who would find a case against what I just said and find a scenario where mix and matching would work? Sure, but I don't recommend it. I don't like it. To wrap up my thoughts about async await and why we should use it, I think hopefully it's clear that we use it mostly to make our code more readable. It doesn't really add any sort of functionality or feature that promise handlers with the then and the catch block don't give us already, but it's just a much nicer, more synchronous looking way of writing promise handlers. Okay, so before I wrap up, a few things. But first, some water. Stay hydrated, kids. So number one, we reached 20,000 subscribers right before I shot this episode. So this is a huge milestone for me, 20,000 on the way to 100,000. The more you have, the more you want, right? So, but I wanted to say thank you all for subscribing. I don't like to beg for likes and subs like some others do. So to see all you guys and gals out there show interest in my work is really rewarding. So thank you very much. Second thing is I'm going to start a ColorCode podcast. I'll be talking about similar type of things that I talk about here on YouTube and do some audio tutorials and see how that works. I don't know too many people who are doing that, so I'm interested in seeing how that works, and interviews with friends and other engineers and other tech people. Just like my old Drunk Web podcast, if any of you have been following me since the good old days, I'm looking for a name for this podcast. If you have any suggestions, let me know in the comments below. And if I choose the name that you suggest, and if I hadn't thought about it myself already, I will send you some ColorCode merchandise. And speaking of, ColorCode has an Etsy store now. So you can buy t-shirts and mugs. The mugs are really cool. It changes color when you add hot water to it, so it can tell you if your tea or coffee is still hot. So yeah, check it out. Next thing is I'm redoing the ColorCode website. So if you see something not working there, it's because it'll be replaced soon with a new version. I plan on making a video episode for YouTube and talking about how I rebuilt it in just a few days. We're using React 18, Next.js 13, the one that just came out, Vercel, Firebase, GraphQL, TypeScript, all that good stuff. Stay tuned for that. Next thing is I've started to post YouTube Shorts, the 1-minute versions of these videos that I'm teaching. So check it out and let me know if you've seen those and what you think of that format. Last but not least, my JavaScript Mastery course. Many of you have messaged me and continue to message me on Instagram and asking me about even on LinkedIn, about what's going on with that and when it will be available. I know it's taking a while. It's taking longer than what I expected, but I have an extremely demanding full-time job outside YouTube, and I'd rather wait a little bit longer and put out the best course that I can put out for you versus rush it and put something mediocre and average out there that you can already buy on Udemy for $5. So more on that later, I promise. I'm working really hard on that. And that's it. I gotta bounce. Thank you for watching. This was episode 13 of the 20-part series called 20 Things JavaScript Developers Should Know But Probably Don't. See you soon. Baby.